Hey guys, welcome to the CNCM round 3 problem 6 solution video. So the problem is right here. Basically ABC is a 13, 14, 15 triangle. Let me label that here. 13, 14, 15. H is the orthocenter, and you have the two altitudes that intersect the circumcircle, and basically we want the area of the red quadrilateral, HDXF. So the 13, 14, 15 triangle is fairly well known. In particular, we can erase this 14 here and replace that with 5 and 9, or split it up into a 5 and 9, and the altitude is 12. So now that we have done that, let's see what we need to do to find the area of the quadrilateral. So the area of quadrilateral HDXF is basically the difference of the area of two triangles, namely HDG and triangle GFX. And so the goal is pretty much to find the area of these two triangles and just subtract them. Let's start by finding the area of triangle HDG. So to do that, basically what we're going to want is the length of HD and the length of HG, as well as the angle DHG. And we can tell that that is 180 minus the degree measure of angle C, because quadrilateral HQCF is cyclic because it has those two right angles, and so the two other angles have to be supplementary. So if we can find all three of those, or those two lengths now, then the area of the triangle is going to be 1/2 times HD times HG times the sine of angle of that angle, which is 180 minus C. However, note that the sine of two supplementary angles are always the same, so that's just going to be equal to sine C. And if we look at triangle AQC, the sine of that's going, if just that triangle by itself is a 9, 12, 15 triangle, and so the sine of C is going to be opposite over hypotenuse, which is 12 over 15, and 12 over 15 is 4/5. Simplifies to 2/5 times HD times HG. Alright, so we need to find those two lengths now. This is a well-known configuration. In particular, the reflection of H across F is equal to G, and the reflection of H across Q is equal to D. And so basically finding HD and HG boil down to finding HQ and HF. Afterwards, we just double those two lengths to get what we want. So let's start by finding HQ. Let's see. So let me erase some of the stuff. To find HQ, Well, we know that this angle is going to be 90 minus C. And since we know BQ, HQ is going to equal, let's see, so it's going to be HQ times tangent of 90 minus C. Or I'm sorry, 5 times tangent of 90 minus C. So that's BQ times tangent of 90 minus C. We know BQ is 5, tangent of complementary angle is the reciprocal, so we're going to have 5 over tangent C. Tangent C equals, so opposite over adjacent gives us 12 over 9. Reciprocate that gives us 9/12, which is the same as 3/4. We're going to have 5 times 3/4, which equals 15/4. Alright, so that's HQ. Next step is to find HF. And to do that, we're going to look at triangle AHF. And so what we're going to notice there is that this angle is also equal to 90 minus C. And the length of AH equals 12 minus the length of HQ. We just found HQ. So we have 12 minus 15/4, which is equal to what? That's 33 over 4. All right, and so let's see what we have here. HF is going to equal it's going to equal AH times sine of 90 minus C. We just found AH to be 33 over 4. Sine of 90 minus C, that's the same as cosine of C. And cosine of C is, well, if we go back here, we have adjacent over hypotenuse, 9 over 15. So that gives us 3/5. So right here we have 99 over 20. And now we're set to find the area of our first triangle. Let's see, so we need, what we had before was that HDG, the area of that triangle, was equal to 2/5 times HD times HG. So that's 2/5 times, all right, so HD is 2 times HQ. So instead of 15 over 4, we're going to have 15 over 2. And HD is 2 times HF, so instead of 99 over 20, we're going to have 99 over 10. All right, let's see what we have. 2's go away, this becomes a 3. And so this whole thing essentially becomes 297 over 10, which gives us 29.7. So that's going to be the area of our first triangle. And now we want to find the area of triangle Gfx. All right, and in order to do that, so we look at triangle Gfx. And so if we notice that BAGD is a cyclic quadrilateral, then it's apparent that, pick a different color, these two angles are going to be the same. However, this one has angle measure 90 minus b. So this also has angle measure 90 minus b. All right. Well, we also know the length of GF is the same as the length of HF, and HF had length, let's see, what did we have here? HF had length 99 over 20. So we're going to put 99 over 20 right here. And at this point, we'll also try to find the length of Fx, because from there, the area of the right triangle is pretty much GF times Fx over 2. All right, so Fx is going to equal, let's see, so tangent is going to equal 99 over 20 times tangent of 90 minus b, which equals 99 over 20 times 1 over tangent b. All right, and tangent b is, let's see, it is opposite over adjacent, which is 12/5. So we have to reciprocate that. That gives us 5/12. So this is going to equal 99 over 48. So that's Fx. So we know Fx, we know GF. So let's finish things up. We're going to have 1/2 times GF times Fx. GF equals 99 over 20, right? Right, and the other one is equal to 99 over 48. So we have 99 over 20 times 99 over 96. At this point, we're just going to use an approximation argument. So 99 over 20, that's roughly 5. 99 over 96, that's roughly 1. So this product is around 5. And 29.7 minus 5 is, roughly 24.7. It's probably an overestimate. And as a result, the floor is going to be 24. And that's going to be our final answer. Clearly, the approach was a brute force trick solution. But anyways, I hope you enjoyed, and I hope to see you later.